I'm Terry Bradshaw, and my team is searching the country to meet the innovative professionals who are on track to become tomorrow's business leaders. This is Business Day. You know, our lives are still dependent on oil and natural gas and their byproducts, but the cheap and easy supplies are gone. Let's see what innovative people are doing to keep up with the rising demand. The operating cost of deepwater drilling rigs can easily exceed $1 million a day. With so much money, time, and resources on the line, mistakes and delays must be avoided as much as possible, if not entirely.
Cementing is essential to well construction. Mixing slurry water and cement, it's pumped down the casing to the bottom of the hole. From there, the cement flows back up the hole, filling the space between the wellbore and the casing. The cement creates a seal, which is a primary barrier for environmental protection, and it helps to support the casing and prevent corrosion.
When an oil and gas well is constructed, a hole is drilled with a bit and casing is run into the hole. Cement is then pumped down the pipe and comes back up the annulus between the casing and the open hole. The cement acts as a seal to ensure that oil and gas only flow up the inside of the casing. Sealing the annulus between the casing and open hole is one of the fundamentals of well construction and gives operators control by only allowing fluids to pass through the conduit of the casing.
Any oil or gas flow up the outside of the casing is known as a loss of well control and is prevented by filling the annulus full of cement. Typically, oil and gas reservoirs lie at 10,000 feet below the surface, and the chances of this much cement failing to seal are very, very rare.
To ensure an effective seal in any well, the casing must be centralized in the hole so that an even thickness of cement can be achieved. Although centralization has been around for over a century, the technology has not kept up with the way modern wells are drilled. With higher grades of casing steel, the traditional means of locating centralizers are no longer effective. And should these fail, there's always a risk that will slide on the pipe and split apart when they reach connection.
Centralizers are held in place by the casing collar or series of set screws. In more complex wells, they could also be crimped in place. Now, as wells have become more complex, the collars have become thinner in diameter or completely flush with the casing and thereby no longer acting as a stop.
To make sure that the cement will make a complete seal in an oil or gas well, WearSox is used to center the pipe in the hole, which ensures an even thickness of cement all the way around it. This prevents high-pressure fluid migration. Our spray metal centralizers have been used as a solution to these problems in over 500 wells globally.
WearSox LP is a manufacturer of both onshore and offshore products for the oil and gas drilling industry. The company has taken the 100-year-old technology of spray metal, which was traditionally used for corrosion and erosion protection, and builds actual metallic shapes with it. The spray metal has created a valuable new tool for oil and gas companies to construct more robust and durable wells.
WearSox was created to implement a new technology to help operators drill and complete their wells more efficiently. Our customers are typically exploration and production companies on both sides of the Atlantic. We're a relatively new player on the scene, but we're already a preferred solution for centralization with today's largest E&P companies.
WearSox spray metal is a proprietary blend of components that deliver hard-wearing and low-friction characteristics. When applied to casing, the built-up shapes take on similar characteristics to the steel, almost as if they grew out of the casing itself.
WearSox is a versatile solution. It's used to create shapes for centralization and is also applied to drilling components subject to high wear, such as downhole tools and drill pipe. WearSox has been successfully applied to different casing metals, including normal high-strength low-alloy steel, high chrome, nickel alloys, as well as titanium and aluminum.
Before applying the spray metal, WearSox grit blasts the pipe to remove all contaminants and oxides, creating a key pattern of a certain minimum roughness.
We believe that through our internal product development, in conjunction with requests from our clients, this will lead to yet undiscovered uses for WearSox in the very near future.